Now let's see how the change analysis in costing is actually performed. So we start by a change request, and then the first stage is to check if this request is valid or not. So we have two options: either to reject the request or we claim that it's a valid request. So why would we reject the request? Because customers may actually may misunderstood requirements in the context and suggest unnecessary changes. So at this point we might reject the request. So once we identified that it's a valid request, we need now to find those directly affected requirements by extracting a list of requirements that might be affected, and then find those dependent requirements. And of course, this with the help of the traceability information. And the outcome of this stage will be the requirement change list. And at this point, you need to propose those requirement changes in aggregation with the customer information, customer feedback. We could either have two decisions: either to reject the request again, or to change or to investigate the requirement changes. The request could be denied at this point because consequential changes may be unacceptable to even user and customers that has created the need for rejected requests. If we're gonna employ that changes in the requirement, we need now to assess the costs of such a change, which would help, which would be implemented by extracting cost information. And then you need to assess the cost acceptability also with the involvement of the customer information. At this point, you need to do a lot of negotiation with the customers. So you could reject the request, or you could accept the change, or you could reject the request. So mainly rejection of the request could be because of two reasons: either because the risk is too high, or because the cost and time required for the implementation of such a change is too high long. So even if you have, after you have done all of this change analysis, you came up with one decision that this request of the change has to be denied or rejected because we have concluded that it's high, there's a high risk, or the cost and time required is too long, or like not feasible. In few more, like after a few more minutes, I will address risk analysis and how you came up with a conclusion that there is high risk or low risk, and what the decision should be made afterwards. So there are different management aspects that we should consider in requirement management. The first one is change management, which we have addressed with the help of the traceability metrics, in addition to configuration management and, of course, release management. For change management, we need to understand how does a customer submit a changes request, and how is this request being monitored, prioritized, and even implemented or denied. In configuration management, we are monitoring or managing the configuration related to versioning, labeling, and tracking code, and other components during the development cycle of a software. Finally, the release management, in which we define how and when different hardware and software would be made available altogether as a product. So we do care much about the change management, but we also keep tracking of management to the configuration and also the release management. There are different tools to support change management in particular. These tools may be provided through requirement management frameworks, or even through configuration management framework. In either of these two frameworks, there are a set of requirement management tools and configuration management tools that actually include electronic change request forms, database to store and manage requests, a change model, which may be initiated as an instance of a model to represent a change, such that people responsible for one stage of the process would actually know who is responsible for the next process activity. Also, we could have information within each of requirement management tool, or even configuration management tool, related to electronic transfer of forms between people with different responsibility, and even electronic mail notification when activities have been completed. Finally, we store information within those tools as electronic signatures, discussion forums, and in some cases, actually, we store information related to direct links to a requirement database. In the market, there are many tools. There is the commonly one is from London Hydro. They do have requirement management. Quebec Hydro. They do have a requirement management tool that is very efficient for requirement management. There is also IBM tools. So there is many tools available in the market that you could investigate. So among all of these tools, I would like to emphasize on different companies that use different tools. And these tools may or may not be tailored to the requirement management task, but they are commonly used for management. Word processor, a very simple way of management by tracking and plugging in documentations and tabular format. Spreadsheet is another tool. Industrial strengths or even commercial requirement management tool, as I said, by IBM, especially the Tours tool, IBM Prerequisite Pro, or even the Borland Calibre requirement management platform. There's also internal tool like the Hydro Quebec, defined by the GEN specification tool. And there's also some open source requirement management tool, like the OSR requirement management tool. You can find more information about it in this URL. And the bug tracking tool like Bugzilla, or collaboration tool like the Twiki. What should we look for in a certain tool? We see types, attributes for requirement and links, specification and models, version and change management, database repository, traceability information, analysis, including impact, completeness, style, and differences, automation and inspection of requirement according to a certain rules, visualization and reports, like more insights about the changes and requirements in such a tool, requirement document generation, so documentation part, even we have monitoring, like maybe a dashboard of requirement status, access control, import and export information, communication with the stakeholders, and even scripting language for automation, and reuse of requirement models and projects information. In a traditional requirement management tool, we should have the following architecture, where we do have the requirement database. Requirement database is connected to requirement querying system, requirement browser, traceability support system, in which it would generate a traceability report. Of course, requirement generator that will generate a requirement report. And the most important crucial part here would be the change control system. In addition to a converter, a requirement converter and a linker, if there is a need to establish a relationship or link to the requirement documentation as an input of the entire requirement management tool. So requirement management implies integration between different modules. What are the main modules that could be integrated in just one requirement management tool? We could have a project tracking tool, a version control tool, a design modeling tool, project estimation tool, and of course a change request tool and a change control tool, and a test management tool. So the integration between all of these tools should be in one requirement management tool. So far, we have talked enough about requirement management, which include identification of requirements, identifying requirements and identifying versions, and then provide a good traceability to requirements and links and relationship between requirements, and of course, provide a good control for the changes. A major factor that we should also investigate when it comes to requirement management, whether it's on the analysis phase or even the specification phase or even inception and elicitation phase, is risk. So we should understand what is risk, how would we provide risk management, and in addition to the risk, to provide risk management, you have to analyze risk. And once you analyze the risk, you will come up with a decision that helps in management to provide a great, an efficient management to risks. So risk in general is defined as the probability of incurring some net loss while actually pursuing a goal. If we are talking about positive risk, so pursuing a positive risk, which sometimes we call it opportunity, it could be a financial investment, may result in either a net gain or a loss. There are two different types of risk. It could be a reducible risk or a reducible risk. What is a reducible risk? A reducible risk is considered as this risk which is predictable or within our control. That means we can predict it. I can control it. If I can predict it and control it, that means we can reduce the likelihood of the loss by taking steps to actually avoid the risk. On the other hand, irreducible risks are more difficult to deal with because they are unpredictable, so I cannot predict them. And also they are beyond our control. So unpredictables, we know the risks can occur, but have no base upon which to estimate the probability of occurrence. Example, like if you loss of a key project resource, at this point, there is no unpredictability that this may happen. So you cannot estimate or know the action for avoiding such risk. Also, it's beyond our control because these risks might be exceptionally unpredictable in a way that may be due to unexpected natural behaviors or complete platform changes have occurred. So these type of risks are handled through business continuity practices, and of course it would need efficient experts to identify the risk and to handle those risks or manage those risks. So for risk management, there are different elements in risk management. So to identify those elements, we need first to identify or define what is risk management. So risk management is defined as a systematic approach in which the goal is to reduce the harm or the consequences due to such risk. That means we are hoping to make a project less vulnerable to changes or even to failure. Risk could be cost or schedule overrun, scope decreases, so like project scope decreases, quality reduction. And at the end, we are hoping that when we provide management to risk, we need to obtain a product that is more robust or sustainable. So using this definition of risk management, what are the main elements of risk management? To manage risks, you need to analyze the risk and control it. To analyze the risk, you need to identify the risk and then to provide an assessment of the risk and provide risk prioritization. To control the risk, we need to provide an efficient risk management planning and risk resolution and risk monitoring. In today's class, I will talk about different risk categories and then the risk management model. And in next week, we will talk about each of those risk management elements separately in more details. So what are the main risk categories? A risk could be a known risk, unknown risk, or unknowable risk. What is or what are the main like known risks? Known risks are those risks that can be uncovered after careful evaluation of the project plan, business, or even technical environment, or any other reliable resource information. We refer to those risks that can be estimated from historical information. And actually, those risks could be easily identified by different management techniques, and even through response plans. Examples of those known risks could be potential delays in delivery from a third party. That's definitely a risk and that can be uncovered after a careful evaluation of the project plan. Key personnel leave project, that's also a known risk. Development system down, that's also a known risk. So on the other hand, the second type is the unknown risks or the predictable risks. Those are risks that can be extrapolated from past projects. Maybe information, maybe those risks were extracted because there is stuff turnover or poor communication with the customer. We refer to those risks that we know we have a probability of occurring, but we don't know the precise impact of such risks. those risks cannot be managed directly, but can be handled by the use of contingency. I'm going to see contingency table to handle those type of risk. Example of those risks could be the loss of key personnel due to turnovers. The second type is unpredictable risks, which we talked about it before, which we call them the irreducible risks. Those unpredictable risks, they are very hard to predict. And finally, the unknowable risks, we refer to those risks that are outside the scope of historical or even probabilistic models for the project. And those risks are beyond the scope of risk management. And those risks actually are knowable. Like I don't have any information about it, either from historical data or I don't have any future forecasting model that help me to provide risk management for those type of risks. Examples, it could be natural disaster, it could be acts of terrorism or war, or it could be even storm, snowstorm, or it could be even like power loss. So that's why we call them irreducible risks. So a reducible risk is a predictable risk. A predictable risk could be a known risk or unknown risks. But unpredictable risks, and if we call them in addition to unknowable risk, we would put them under the family of irreducible risks. Those are unpredictable and those are beyond our control. So to build a risk management model, there are major steps that we need to perform, starting from risk management and planning step, going to risk identification, with identifying the risks, provide a qualitative risk analysis, and then a quantitative risk analysis, and then develop a risk response planning to help in risk monitoring. And finally, that will clearly provide an efficient risk control procedure by tracking and auditing those risks in a risk history, or we call it risk register. This again will cycle into the risk management phase or like process. As you can see here, there is always a feedback loop between every component in the risk management tool, because we always need a feedback between each pair of those components, between evaluation and revision of risks, between evaluation and revision with the tracking, evaluation and revision with the risk identification, evaluation and revision with the qualitative risk, or even quantitative risk, and even the risk monitoring. There is always a feedback between each of those components and their evaluation and their revision analysis. So I will stop here at this point, and next week we will talk about risk management techniques, including risk analysis and risk control. We will address different techniques that are commonly used in analyze risks and identifying risk and assessment to risk and even prioritization to risks. And then the risk control, which would include planning for the risk, and then the resolution to the risk, and of course, monitoring to the risk. Thank you for listening for today's class.